Ogura produces a wide variety of electromagnetic clutches and brakes. In this troubleshooting video, we will primarily focus on single-surface electromagnetic clutches and brakes, which are the majority of all electromagnetic applications. Although the majority of electromagnetic clutches and brakes used in the industry are single-surface, many of the areas we will review will also apply to other types of electromagnetic clutches and brakes, such as multiple disc, tooth, spring-applied, and magnetic particle. Although there are many sizes of electromagnetic clutches and brakes, from very small to very large, the function of the components is the same. All electromagnetic clutches and brakes actuate electrically but transmit torque mechanically. The key components of the clutch are output, which can be direct connected or have a pulley or timing belt like the example shown here, armature, rotor, and field coil. When voltage or current is applied to the clutch, the coil becomes an electromagnet and produces magnetic lines of flux. This flux is then transferred through the small air gap between the field and the rotor. The rotor becomes magnetized and sets up a magnetic loop that pulls the armature against the rotor. For a brake, the key components of a brake are field coil, armature, and hub. When voltage or current is applied to the brake, the coil becomes an electromagnet and produces magnetic lines of flux. This flux travels through the small air gap between the field coil and the armature, magnetically pulling the armature against the hub and creating a holding force. When current voltage is removed from the brake, springs hold the armature away from the hub surface, creating a small air gap. Single-surface electromagnetic clutches and brakes normally have a single flux design for industrial clutches. This means that there is a north and south pole, and between the poles, there is friction material to help increase clutch or brake cycle life. When many users look at an electromagnetic clutch for the first time, they see that friction material is flush with the inner and outer poles, thinking that the material is already worn down. This is not the case. In order to transfer torque, a magnetic flux connection has to be made between the steel poles and the steel armature plate. For many mobile applications, double flux and/or triple flux clutches are used. These multiple flux clutches allow for greater torque in a smaller area. These clutches are typically steel-to-steel contact, so although torque is higher, cycle life is lower. They are usually used in automotive or off-road equipment. With this in mind, to troubleshoot electromagnetic clutches or brakes, we look for problems either electrically or mechanically. In all cases, before performing the following checks, make sure all power is turned off and, where possible, remove the clutch or brake from the machine. In electromagnetic clutches and brakes, there are three main potential issues. They are engagement, noise, and excessive slipping or heat failure. Before proceeding with engagement checks, make sure the shaft going through the clutch or brake can rotate. If it does not rotate when there is no power applied, a bearing may be locked up. If this is the case, check for bearing failure. Engagement. Engagement can be broken down into three sections, which are: the clutch or brake won't engage initially, the clutch or brake won't stay engaged after it is running, the clutch or brake won't disengage. Won't engage. Electrical. Is the clutch receiving the proper DC voltage? Make sure the voltage coming from the source is the correct voltage required for the clutch or brake coil. The voltage for the clutch or brake coil is typically listed on the label. Undervoltage may prevent the armature from pulling in, but overvoltage will cause the coil to short out and fail internally. Check the fuse to see if the fuse has blown. This can be on the AC or DC side. Check the lead wire of the clutch or brake to make sure there are no cuts or that the wire isn't crushed. Check the terminal connections on the clutch lead wires and on the power supply to make sure they are tightened or not damaged. If the clutch or brake is receiving the proper voltage, the next thing to check is the clutch coil itself. Does it look like it is discolored or burnt? Either way, it is best to check the ohm rating on the coil. At room temperature, this should compare with the ohm rating listed on the clutch or brake data sheets. If you notice discoloration on the coil shell or on the faces of the clutch or brake, the coil may have failed as a result of slippage or physical contact during rotation. Failure can occur if the field and rotor make contact with each other. This would be evident as a blister point on the coil, or if a clutch rotor is dented, this could cause contact. If the clutch shows signs of slippage or excess heat, refer to the slippage section. Won't engage, mechanical. If the voltage and coil are okay, then the possible problem is with the air gap. The air gap between the armature on a clutch or the armature on a brake field is critical. If the air gap is too large, the magnetic field cannot make the jump across the gap and pull the armature to make contact. If the air gap is set correctly but the armature doesn't move, then there may be some other obstruction preventing the armature from being pulled towards the rotor. Carefully check the movement of the armature to make sure it has free movement to the rotor or to the brake field. You should be able to push on the armature plate and see movement. The springs will always bring it back to its set location. Again, make sure the power is off when you do this, otherwise your fingers will get pinched. On some clutch series, the air gap adjustment is automatic. On others, you can reset the hub to reset the air gap. However, there are limitations, because at some point, the wear on the armature will be too great, and it will not be possible to adjust the air gap for wear. At that point, the clutch or brake would need replacement. If the clutch armature is engaging, but the load is not engaging, the key may be missing on the shaft, so the shaft would just spin inside the hub or the rotor. In most clutches and brakes, torque is transferred through the springs. If the clutch or brake is subject to heavy, reversing, or shock loads, the armature spring or springs may be broken, so torque cannot be transmitted. If everything checks out and the clutch is operating but not picking up the load, then the clutch is slipping. Refer to the slipping section. For specialty clutches like tooth or multiple disc, there are two other things to look for. For a tooth clutch, it needs to have some relative rotation and load to engage. Otherwise, you could have tooth-to-tooth contact during an attempted engagement. For multiple disc clutches, if heavy vibration is present over long periods of time, the tangs of the friction disc can wear into the drive cup, preventing full engagement. Won't stay engaged, electrical. Check to make sure the switch is okay. Depending upon the installation, there are a variety of switch options that can be used. Some are direct, some are indirect. You may have to check not only the switching mechanism controlling the clutch or brake, but any other relays that may be in the electrical system as well. An intermittent or malfunctioning switch can cause a clutch to cycle, which can induce slipping. Check your voltage to make sure it is consistent and not varying. If the voltage is varying, the cause could be on the DC side or on the AC side of your power supply. Check the lead wire to make sure there are no cuts, and to make sure the wires in the terminals are properly crimped and making contact. Also, a crushed lead wire could have breakage internally. If you get an intermittent reading while moving the wire, the lead wire is damaged. Won't stay engaged, mechanical, electrical. Check for signs of heat. If excessive slippage is noted, the coil could be damaged. As coils heat up, the insulation coating on the magnet wire can break down. This causes electrical leakage and higher amp draw in the coil and less torque available in the clutch or brake. A coil at room temperature may appear to be normal, but after it heats up, it may have a higher amp draw. To test for this, connect the clutch or brake to the power supply for approximately 2 hours. If there is a significantly lower ohm reading, the unit would need to be replaced. Won't disengage, electrical. Confirm that the voltage is being turned off to the coil when required. If voltage is not being switched off, then the switch may be damaged and needs to be replaced. Won't disengage, mechanical. Check the armature and make sure that there is freedom of movement. A slight air gap should be created when clutch power is off. Most clutches have springs to pull them back to maintain an air gap. Make sure that there is nothing pressing on the armature, such as a screw or fastening mechanism. The clutch could be galled. If a clutch is unburnished and slips, metal chips can flake off and the clutch can become galled. Sometimes they can get caught between the plates, and because of the pressure, they melt, and the clutch or brake can become friction welded together. For a clutch, the armature sleeve or ball bearing may have failed. If the bearing on the armature is locked up, the clutch will want to drive when there is no power applied. For multiple disc clutches, alignment of the drive cup and the friction disc is critical. If these are misaligned, this can cause binding and prevent the clutch from properly disengaging. For magnetic particle clutches, magnetic particle powder can sometimes be packed due to vibration. Powder can be released by tapping with a rubber hammer and then cycling the clutch or brake to redistribute the particles. Additionally, with magnetic particle units, if the heat dissipation rating is exceeded, bearing seals can break down. Powder can migrate into the bearings, causing the bearings to lock up. This can be felt during rotation by hand. If this is the case, the clutches will need to be replaced and cannot be repaired. Noise. In almost all installations, noise is a mechanical occurrence. There is noise when a clutch or brake engages. If the noise is extreme, the clutch or brake may be undersized for the application. Also, in many belt-driven applications, there is noise coming from the belt and not the clutch or brake. The noise you hear will give you an indication of where to look, but there should be no noise from a clutch after it is engaged or a brake when it is disengaged. If the noise is an intermittent scraping sound during rotation, it is possible that the armature may be too close. Back off and reset the air gap. Make sure that there is no damage on the armature, causing it to be deflected towards the rotor. For mobile clutches, the cover plate may be bent, pushing on the armature. The cover plate can be pried back, creating a proper air gap. For PTO clutch brakes, the air gap may be too small. Check the air gap with a feeler gauge and back off if necessary. Is the clutch or brake hub able to move on the shaft? If so, it is possible that the key is not inserted correctly, or the set collar or other device used to keep the clutch or brake hub on the shaft is somehow loose, and noise is coming from movement. If the noise is present in a bearing-mounted clutch when it is disengaged, but the shaft is rotating, then the noise problem can be with the field or pulley bearing bushing. If the clutch feels rough or there is noise present during rotation, the bearing has failed. Good bearings should spin freely with no noise or vibration. Noise from bearings in the clutch or brake can be from brittling, which is physical damage to the bearing races from excessive vibration or shock load. False brittling can occur if the bearing races have no relative movement for long periods of time and are subject to vibration. A noisy bearing is an indication that the bearing will eventually fail and the clutch or the bearing need to be replaced. Check the torque tab to make sure the torque tab has free movement. The torque tab should not be tightened down. This will cause field bearing failure. If the noise goes away when the clutch is engaged, then the noise is coming from the pulley, hub, or sprocket bearing and needs to be replaced. To determine the cause, check the following: axial or radial loading. Check the loading and make sure the bearing or bushing load is not exceeded. Bearing seal. If the clutch has a ball bearing, check the seal area to make sure the seal is still intact. The seal could have been physically damaged, or in many cases, in outdoor applications, the grease can be blown out from pressure washers. If you think this may be the case, you can remove the seal to check. However, once the seal is removed, it is very difficult to replace, so the bearings may no longer be functional. If the bearing is burnt or discolored and the clutch is also discolored, the bearing could have failed due to high heat generated from either an outside source or slipping. If slipping is suspected, please refer to the slipping section. Inspect the armature and rotor for damage. If the rotor is bent, dented, or contacting something else, that is the noise source. If you have a two-piece clutch and noise is noticed during engagement, there could be mechanical interference between the rotor and the field coil. This noise would be different from the intermittent scraping noise that would occur with the armature set too close. It would be more of a constant noise. This is known as rotor strike. Rotor strike is the most common noise occurrence and is also the most common reason for eventual failure in two-piece clutches if it is not corrected. Rotor strike typically means that the concentricity is off between the shaft holding the pulley armature assembly and the backing plate holding the field. If the noise is noticed, the clutch needs to be taken off and reassembled. If the armature is warped from slipping, it can drag against the rotor. Excessive slipping. The most common failure for an electromagnetic clutch or brake is that it has slipped, or slipped to the point where it is burned up. Diagnosing the problem can be a little tricky because when a clutch or brake has slipped to the point where it is burned and no longer functioning, multiple component failures may have already occurred. Heat is the enemy of a clutch or brake. If the clutch or brake cannot dissipate the heat being generated, its ability to transmit torque degrades. Excessive slipping. Electrical. Check to make sure the proper voltage current is going to the clutch or brake. If you have a constant current supply, the relationship to voltage and torque is almost linear. What this means is if you have a clutch or brake with a 12-volt coil and you are applying 8 volts, you are only going to get 2/3 of the torque out of the clutch or brake. Make sure that the input to the clutch or brake is at its rated voltage. Make sure the lead wires are not cut or crushed. If the lead wire has damage, the coil will not receive full voltage, or it can be receiving intermittent voltage, which reduces the ability of the clutch or brake to transmit its full torque. The internal magnet wire may be damaged due to high heat. Check the ohm rating at room ambient temperature and then apply voltage to the coil. Depending upon the size, it may take up to 2 hours for the clutch or brake coil to saturate its temperature. Then, take a reading. It should be a little lower. If there's a drastic difference, the clutch coil is already damaged due to heat, and the coil will have a higher amp draw. Excessive slipping, mechanical. Contamination. Clutches can slip due to contamination, so all lubricants should be kept away from the contact surfaces, the exception being a wet multiple disc or tooth clutch that is made to run in oil. Clutches used in outside environments typically do not contain friction material because sometimes if friction material gets wet, it can swell, preventing the clutch or brake to completely connect the magnetic circuit, lowering the torque and causing slippage. Overloading of a clutch or brake can cause it to slip. This is obvious in the case where a heavier load is required to start or stop, but can be tricky sometimes if it is simply just a change in RPM. This formula shows the amount of torque required to accelerate or decelerate a given inertia at a given RPM. If the inertia and response time of the clutch or brake remains the same and there is simply a change in RPM, say from 200 to 400 RPM, the formula will show that twice the torque is now required from the clutch or brake to keep the same response time. In a case where overloading is suspected, both load and speed should be evaluated. There are other factors that influence the torque in a clutch or brake. The surface friction can be influenced by contamination on the surface, temperature, and the condition of the surface. Most mobile clutches do not have friction material and are steel on steel. To develop maximum contact area, the clutch or brake needs to go through initial cycling, burnishing, to wear down these high points. Unburnished clutches can have a 20 to 50% reduction from their catalog-rated torque, so a new mobile clutch that was unburnished can develop galling. Galling is glazing of the surfaces, which drops the coefficient of friction and reduces the amount of torque the clutch or brake can develop. A low hour slip failure is normally due to lack of or improper burnishing. Pressure is influenced by coil resistance, voltage, and current. Outside heat can affect the ability for the coil to generate flux. Basically, the hotter the temperature, the weaker the coil becomes. If the power supply is not constant current, like it would be in most mobile or battery applications, then coil flux can degrade as the temperature rises. Torque spikes in excess of the clutch or brake's rating will cause accelerated wear or slipping. Clutches that are mounted on gas or diesel engines will require an additional torque service factor, which can be 4 to 5 times nominal engine torque, to withstand piston and crankshaft torque spikes. We hope this gets you on your way to troubleshooting electromagnetic clutch and brake issues. If you have other questions, feel free to visit our website, www.ogura-clutch.com, or email us directly at info@ogura-clutch.com.